Is it possible that some systems in nature not only evolve, but actively rewrite the very rules by which they evolve? Welcome to DeepVisus, where we peel back the layers of visionary texts in complexity science, philosophy of mind, and theoretical biology. In this episode, we dive into the opening chapter of George Kampis's groundbreaking 1991 work, Self-Modifying Systems in Biology and Cognitive Science, a text that dares to rethink what it means for a system to change, evolve, and know. Kampis's book is a sharp departure from classical science. It's not just a critique, it's a philosophical expedition. Published as Volume 6 in the International Series on Systems Science and Engineering, this book proposes a radical rethinking of dynamical systems. Kampis introduces a new type of system, what he calls the component system, a self-modifying, information-generating, structure-changing process that challenges the legacy of Newtonian physics and Turing-based computation. Chapter 1, simply titled Introduction, opens with a bold premise. The universe is creative, not metaphorically, but literally, capable of generating new forms, new information, and new internal structures through its processes. This is the world of galaxies and brains, enzymes and thoughts. But if such creativity exists, Kampis asks, why are our scientific models so poor at describing it? He turns a critical eye toward traditional science, especially computational and mechanistic approaches in biology and cognitive science. In these models, systems are state-determined. Everything is governed by predefined rules. Yet real-life systems, organisms, minds, even evolving populations don't just follow rules. They seem to invent new ones. Kampis illustrates how biology and psychology have clung to the security of mathematical formalisms, differential equations, automata, and neural networks, while ignoring the radical implications of creative evolution and cognition. Through compelling examples, from rat cognition to evolutionary feedback loops, he shows that traditional models, even when mathematically correct, often fail to distinguish between fundamentally different theories. Mechanistic behaviorism and representational cognitivism, for instance, look identical in dynamical equations. This, Kampis says, is a symptom of a deeper problem. Our tools are too rigid for the systems we aim to understand. So what does Kampis propose instead? He hints at a new modeling paradigm where systems are not fixed in their identity, but construct themselves as they go. Such systems cannot be fully described by fixed sets of variables and laws. They are non-Turing, non-mechanistic, and non-equilibrium. They are what make life, thought, and evolution possible, not in metaphor, but in physical, empirical, dynamic terms. Chapter 1 is a manifesto, a challenge, a philosophical scalpel that cuts through the frozen metaphors of classical science and asks us to consider a universe where dynamics is not just about change, but about the transformation of what it means to be a system at all. If you've ever felt that complexity, life, or thought are more than the sum of their parts, Kampis offers a framework to say why. That's all for this episode of DeepVisus. In our next episode, we'll turn to Chapter 2, where Kampis lays down a constructive approach to modeling, an epistemology of complexity where observation itself becomes a creative act. Until then, stay sharp, stay curious, and remember, not all systems follow rules. Some write them. DeepVisus, where vision meets depth.